Ever downloaded a shiny new program only to realize it wants you to cough up some cash before you can use it? We've all been there staring at that paywall. You might even have been tempted to venture into the shady corners of the internet to find a workaround. But have you ever wondered how these activation mechanisms actually work and how hackers or crackers manage to bypass them? Programs are written in languages like C++, Java, and Python. These languages are super friendly for humans, but absolute gibberish to computers. To bridge this communication gap, the code gets translated into machine code, a glorious mess of ones and zeros that your computer can finally understand. This transformation process is called compilation. So instead of high-level commands, you get to deal with cryptic instructions like move EBX23, which is just a fancy way of telling the computer to put the number 23 in the EBX register. Software activation checks come in two flavors, online and offline. Online checks are the nosy ones. They verify your ownership by chatting with a server somewhere out in the cloud. You type in your key and the software sends it off along with the unique identifier of your machine. The server checks its list, and if your key is legit, it sends back a thumbs up and your software is activated. Offline checks, on the other hand, are more like an introverted puzzle. These algorithms can range from simple, like checking a basic pattern, to brain-meltingly complex involving cryptography and stuff that makes you wish you'd paid more attention in math class. Enter the crackers, who make it their mission to bypass these activation mechanisms. They use reverse engineering, which is a fancy term for taking the software apart to see how it ticks. To do this, they wield tools like disassemblers and debuggers. Disassemblers turn machine code back into assembly language, making it slightly more readable. Debuggers let crackers run the software step by step, pausing at will, to poke around and see what's happening under the hood. The process usually starts with the cracker hunting down the activation code, often by searching for telltale strings like invalid key or activation required. Once they've found the code, they study how it works. This might involve checking specific bytes, calculating a checksum, or decrypting some data. After understanding the activation process, they tweak the code to bypass it. This can mean replacing critical instructions with NOP, no operation commands, or changing conditional jumps to alter the program's flow. With the code modified, crackers create a patched version of the executable, often distributing it alongside the original installer. Users then replace the original executable with the patched one, and they've got a free, albeit illegal, copy of the software. But software developers aren't just sitting around twiddling their thumbs. They've got tricks up their sleeves to make reverse engineering harder. Code obfuscation makes the code look like a tangled mess of spaghetti. I'm going to crack a reverse engineering CrackMe program. Just a heads up, these CrackMes are made specifically to be cracked. I'll be working on a CrackMe called Pride Crack C by Pride. It's written in C or C++ and is a 32-bit program. Enter the name bread and use the generated key. It works, and that's how we crack this program using X32DBG. Now here's the serious part. Using cracked software is illegal and it's risky. You could face legal consequences, and cracked software often comes with unwanted bonus features like malware. Plus, you miss out on support and updates, leaving you vulnerable to bugs and security vulnerabilities. So while the technical wizardry behind bypassing software activation is undeniably fascinating, it's best to stay on the right side of the law. Thanks for tuning in, and as always, stay safe.